5 microliters that we'll want. So yeah, we got about 10 microliters of the final library. We're only using 3 microliters of it for the sequencing run. So you can potentially do, that's kind of the amount of DNA that you get. You can do a few sequencing runs from one library prep if you need to. Just do that for now. Do that just hasn't thawed yet. Just hold that in my fingers. All right.
Dice que no.
¿No tiene?
Fungal don't check.
No, it's just 7 pores available. Okay, no, we can't use that one. Okay, just throw that in the bin. This is 117 microliters of this stuff called FCT. No, FCF, which stands for flow cell flush. Just a little bit of ice in there. Let's just shake that. Other things still frozen. I don't think it needs it, no. Just shaking. It's just one of these things is still. And then it is 3 microliters of this FCT, which stands for flow cell tether. I'll just vortex that in first. That doesn't have your DNA library in it, but you have to add it first. See how I'm doing this? We kind of grab it where these triangles are, pull up like this, pull back like that. That's this direction. Pull back like that, and you can kind of stick. They're slightly sticky there, so you can get it out of their way. Can you see like the drop of liquid there on top of the greenish part? So that is the port that you actually pipette into. So I'm going to need to grab a pipette, sorry. It's called FCF and FCT. And they're just part of the kit. So you take all of it. And it's important that there's no air bubble or anything at the end of the pipette. So I always kind of turn it down just a little bit so that there's absolutely no air gap there. And then you put it in just so that it sort of sits snugly in the hole there. You will feel a kind of a V shape where it goes in. And you have to pipette very, very slowly because it's important, again, not to introduce any air bubbles. So the way to do that is actually turn. You turn the dial so that the volume is going down. So can you see the liquid? It is pushing, but that's like as slow as you can push. So turn, turn, turn. And you may see, well, you guys won't be able to see, but there is sort of a channel that you should see liquid start to move through as it goes in. Just going slowly and carefully is the key thing here.
This is the sample port.
Sorry?
Oh, this is the sample port.
The sample port. The flongle only has one port.
One port.
It's used for both priming and sample. The mini-ion flow cells, if you've used them, you know they have two different ports. But yeah, that's not what we're doing here. Yeah. Yeah, okay. So I'm going to take this to 30 microliters, which is kind of about as low as you typically want to go. Well, you can go a bit lower. But anyway, for the last bit, I'm just pushing with my thumb, but just, again, as slowly as I possibly can, like that. Because you do this wrong, you shove a lot of air in, and then the whole thing will fail. Okay, and you want to, not absolutely all of it, but leaving like about a couple of microliters in, just so you're not putting everything in. Okay, that's ready, so now it's ready for... And 15 microliters of this thing called library beads, which are not magnetic beads, they're like Sephiros or something like that, they're white. Just mix these in. Okay, so we do this.
La muestra, ¿no?
It's 10 microliters of the beads. It should look kind of like milk when you pipette it. Again, it's important the beads are homogenized. White, kind of like milk. Leche. I know a little bit of Spanish, not very much. Bubble in it, I'll centrifuge that. The whole thing, or almost the whole thing. So you see you pipetted pretty accurately, you know, you can take all of it, that's everything that's there. And do that down just a little bit again. And this. Because the volume's low, you can't really do that dialing down trick that I showed you before, but again, it's just pipetting in very, very slowly with your thumb, as slow as you can. So that's our actual library going in. I'm just going to sleep. And again, leave just a little bit in. And that's it. So we cover it up. We take this kind of tape part here. Just fold it over, kind of push down like that. And that's ready to go. Okay, so we go to the start sequencing screen. Kind of too small for you guys to see clearly. Start sequencing, it's the top option. Okay, so we need to give our experiment a name. So I'm just going to call it course. Yeah. C-O-U-R-S-E. We got something like, can I do spaces and underscores and things? Yeah, underscore 2025 07 22. Is it 22nd? Yeah. Okay. You can put in a sample ID as well, but you don't have to. This one is optional, but there has to be an experiment name. The flow cell ID is the same thing we already typed in, that AWA318. Continue. You need to tell it the kit you used, which is the ligation sequencing kit, so that's the first one there. Expansions, yeah, we ignore all those. Continue. Base calling. We can try to have it do base calling. that means that this will do the conversion of those electrical signals into actual DNA bases. I think it can be slow for this. Ah, interesting. This doesn't actually have super accurate. I think what I'm going to do is fast base calling to get results quickly, but we can also gather the raw data off it, which are called POD5 files, and we can do super accurate base calling on those with the laptop, the computer that we have, which will be more accurate data. It's just that needs a really faster processor. Okay, so let's go with that. When it says barcoding, that means that's talking about native barcodes. That is their version of UMIs, not biodiversity barcodes. Advanced options we're going to ignore. You can set the length of the run. By default it's 24 hours, so I'm going to leave it at that. File output options, probably just leave as the default. Yeah, I'm not used to using this device. Don't know what it means by filtering. Filtering. Q-score, that's like a measure of quality. You can set a minimum read length or a maximum read length that it'll allow, but I'm not going to do that. I'm just going to ignore those, so cancel. And that's it. I'm just going to say start. And that should be it sequencing. So it takes a couple of minutes to get going, but once you look back